Hi, Peter. Really excited to talk to you today about your company and the technologies that you have been developing for your vehicle. And first of all, let me begin by saying thank you for taking the time to do this interview, and congratulations on designing an astonishing car.
Oh, well, thank you for inviting me, Harry. It's a great pleasure to join you. Thank you.
So since we are very tight on time, I'm just going to jump straight to the questions if you don't mind.
Oh, great.
Okay, so first of all, let's just start with some general company-related questions. How many pre-orders have you received to date for each model? Can you share some numbers?
Well, I can't be really specific, but I can say I'm delighted. We've got many thousands. And it's a real pre-orders because people put down up to $7,500 to order in the instance of a Dream Edition. So this isn't just like click 5 tons, I've ordered 5 for free. These are real money down, and many thousands.
Okay. And you've gotten orders for each model or just some of them? Because I know
A nice spread, yeah.
Nice spread, okay.
Dream Edition, which is coming spring 21.
Right. Well, what are your thoughts about going from concept to mass scale production? Elon has, as you probably know, Elon has made references to this being the hottest task for any car manufacturer. So how are you dealing with this? Are you still on target?
Well, we came up with our alpha cars, which are beyond the concept. Some people have got just concept cars.
Right.
We came out with alpha cars a few years ago, and which was sort of 80% production representative. We're currently completing a run of 80 beta prototypes. Many people don't realize we've got nearly 80 beta prototypes, which are 95% production representative. The next step is to go to what we call RCs, release candidates. And those are true pre-production cars to mimic the production process, where we fine-tune the process and the build quality. We're starting building those late this year. Late November, early December. We can commission our paint shop around November the 20th in our new factory, and we start building our release candidates late this year. So that's the next step. And then we fine-tune that process, and then that morphs through February and March into start of production proper. So I don't see this as a huge jump into the deep end, as it were. This is a series, a sequence of very structured baby steps to get us there.
Right. So do you expect any changes to the vehicles before they hit the production line?
Not in terms of anything that a customer would really recognize aesthetically or design-wise. But right now, there's literally hundreds of small changes taking place. We've got a list of what we call ECRs, engineering change requests, and they're going through as the engineering teams are fine-tuning and making detailed revisions to the fit and finish of parts with suppliers, learning from our prototypes. Now, if you didn't have that process, you wouldn't have the time to embody all the learning from the beta fleet of prototypes that we're currently completing and get that learning into the production cars.
Okay. So minor changes might happen, but nothing that the consumer might be able to see or realize.
That's right. And a myriad of minor changes. There's details everywhere, thousands of parts. Literally, at any one stage, at any one week, we've got typically like 150 engineering change requests going.
Okay.
And we'll funnel that, and that'll gradually reduce as we approach start of production proper. But that is a very healthy process.
Yeah.
Because if you didn't have that, you wouldn't have that learning, that loop being closed, the feedback from the prototypes into finished product. And if you didn't have that, there'd be no need to build prototypes, because you'd get it right first time.
Exactly.
That's a theoretical possibility, but a practical impossibility.
Yeah. Well, as we have seen from Tesla and their approach already, when they initially came up with Model S and then Model 3, there have been a number of changes that have happened over the course of the lifetime of the vehicles, and they're still making changes and minor changes here and there that increase the range, make the car more efficient, some interior changes. So do you expect some similar changes to Tesla's happen in the future?
Oh, absolutely. We're committed to continuous improvement. So this is the goalposts are forever moving. The car will mature like a fine wine. It'll get better and better and better. And this is one of the wonderful things about over-the-air updates. So much of the car is software these days. We at Lucid are much a software company as a hardware company. And through our over-the-air ability to upgrade the software, that's the wonderful thing, that the customer's product will improve through the period of ownership. This is quite revolutionary, and hats off to Tesla for pioneering that, and absolutely we bought into that 100%.
Yeah, and this is something that I've noticed that not too many car manufacturers are implementing yet. I noticed General Motors are now getting to the over-the-air updates, and they're getting more into the software side of business, but many others are still trying to figure it out. So I think as a company who's sort of following Tesla's footsteps in this regard, I think that's a great step for the future, because these cars are electric and there's a lot of software involved. So you can do many tweaks and changes just from the software alone. So the over-the-air update, I do believe that it's a very, very crucial thing to have in vehicles today.
And it's one of the reasons Lucid's based in Silicon Valley, to leverage all the wealth, the riches of software talent in the area.
Right. So before moving to more technical questions, my next question is about something that Elon said on Twitter just the day before your unveiling event. So I'm quoting him here. He said, quote, "Rawlinson did not design Model S. Prototype was done before he joined, and he left us in the lurk just as things got tough, which was not cool," unquote. But he did add that you did make some contributions to body and chassis engineering, but not to powertrain, battery, electronics, or software. How would you respond to that?
Well, I was chief engineer. My title was Chief Engineer of the Model S program, and after a few months I was promoted to Vice President of Vehicle Engineering, and I worked in those two jobs for 3 years, and at the end of that 3 years I decided to leave. So I'm very content with my contribution, and the engineering teams all know what my contribution were, and they're the people that matter.
Okay. Was there any particular reason why you chose to leave Tesla?
My mum was taken seriously ill, and I had to go back to England to her.
Okay. Right.
90 years old. So I had a personal crisis, and that's why I had to leave.
Okay. All right, I'm gonna move on to a little bit more technical questions now. And the first one I have here is, why did Lucid choose to go with a 900 volt system? What are the advantages of having a higher voltage? Wouldn't it generate more heat, for example?
That generates less heat. Heat is a product of current squared times resistance, I squared R. And because power is watts, and that's voltage times current times amps. Volts times amps. It is watts. That's how you calculate watts. For a given power in watts, if you double the voltage, you halve the current, and therefore you quarter the I square R losses. So we've got, compared with a Tesla, which is inherent, they say a 400 volt system, we're 924 volts with Dream Edition. So the I squared R losses are about 1/5. And this is an aid to efficiency. But Harry, one of the things that's really misunderstood, it's a commonly held belief that higher voltage actually speeds the cell's ability to charge. And that's a myth. It doesn't actually do that, because we're using cylindrical cells, and they each charge at about 4.2 volts. So although the system level voltage is 924 volts, each cell just sees 4.2 volts to charge. So actually, it doesn't matter what voltage the car runs at. That has no effect on the cell's ability, speed that an individual cell, and therefore the battery pack as a whole, can charge at. So there's no inherent advantage in terms of charging speed, having a car at 100 volts, 400 volts, 800 volts, or if it was plugged directly into a nuclear power station, it was running at 20,000 volts. It wouldn't affect, that's quite shocking, it wouldn't affect the rate of the speed of charge at cell level, and therefore at battery pack level. But there are other inherent advantages. The wiring through the pack and through the car, the charge cables to the car, that's where you see a reduction by a factor of 5 in the I2R losses. And that's a significant practical advantage. There's also efficiency gains when it goes into the drive unit through the silicon carbide inverter. And if you look at the big picture there, there's an inherent advantage in going high voltage. High voltage is an advanced future architecture. I wouldn't want to be stuck at 400 volts. It's the wrong solution. For a future-looking advanced electric car, you don't want to be stuck at 400 volts.
Okay.
It doesn't affect the speed that the cells charge, and that's one of the big myths out there.
Okay, that's good that you corrected on that, because I've been also under the impression that it might help with the charging of the batteries, but that's good that you cleared it up now. So
it does, because there's less heat generated at system level.
Right.
So the cables don't get so hot, and you haven't got such cooling issue. So in that practical sense, it does. But if you look at a dumb little cylindrical cell, we use 21700s, little cylindrical cells. It's the same with the 650. That little cell doesn't know, it doesn't have the intelligence to know what voltage the car is operating at. All it sees is 0 volts at one end and 4.2 volts at the other. If you give it much less than that, it's not going to charge. If you give it a lot more than that, bad things will happen.
Exactly. Before I ask more questions about the batteries, I have a couple of questions about the powertrain. What can you tell us about the powertrain? Because from what I can tell from the unveiling event is that it's quite compact and lightweight. So how did you do this while having high efficiency and high power output? And before you answer this, I've heard rumors that you're using permanent magnet synchronous motors. Does this have anything to do with it?
Oh yes, absolutely. The permanent magnet synchronous motors are more efficient. And Tesla has pioneered their use, moving from induction motor with the early Model S, introducing the PM motor with Model 3, and so on and so forth. But it's not just that we've got a PM synchronous motor, it's the most advanced of its type in the world. It is significantly more advanced than anything else out there. For its power output, it's 2.5 times more compact than the nearest competitor, for example. And that's really important to get the compactness and the efficiency. The efficiency to give us range, and the compactness to make the space concept of the vehicle work. And really, I took a huge gamble, really, with the whole space concept, because we designed a car from the ground up on the premise that we would be able to miniaturize the drive units and the battery pack to a lesser degree. And the space concept is the notion that the Lucid Air is smaller on the outside, more compact. It's smaller than even a Porsche Taycan on the outside. Yet people think it's this huge car. They see pictures of the spacious interior, And it's a natural sort of psychological step to think, oh goodness, that must be a huge car on the outside, and it's not. But we've got a car which is shorter and narrower than Taycan, and a Model S actually, with more interior space than an S-Class Mercedes long wheelbase. And one of the key enablers has been this miniaturization of the drive unit. And when I refer to a drive unit, I mean the motor, inverter, transmission, and differential, the whole thing. And our drive units are 74 kilos and 650 horsepower. We're achieving over 40 horsepower per litre. And that's not at motor level, that's a complete drive unit level, the four elements. Achieving 40 horsepower per litre at a motor level is one thing, but that's including the inverter, the motor, the differential, and the transmission. So these are two of the aspects that we've really pursued with the drive unit: the miniaturization and the efficiency. But there's a third which I haven't really been able to demonstrate yet, and it's less tangible, but will come to bear. And that is we've designed for truly mass production. And that's perhaps the least expected dimension of our technology, because after all, we're designing a relatively lower volume, higher end product to start with. But my passion is to help mankind really transition to sustainable mobility. And we're only going to do that with true mass producible designs. And that's what we've really focused upon with the Lucid Air Powertrain, our drive units. Now, I've not been able to show anyone outside the company what's inside those drive units yet. We've shown some computer graphics giving a sneak peek, but it's still fairly top secret what's in there, because there's some very, very special technology. There's stuff that no one else has ever done before. And closer to start of production, I will open the box. I promise I'll open the box and show the world what we've done and how amazing the technology is in there. But there's a reason why I have to keep that secret right now, because the competitors will be onto it in a flash.
Well, that's very fair and understandable. But yeah, like you said, it's only 74 kilograms, and I feel like that's very impressive, how you be able to make it in such a small compact size yet get that much efficiency and power output out of it. And I'm really looking forward to actually hearing and seeing more information about how you did this, because it's something that I was having a hard time actually believing when I first saw the unveiling, and from the comments that I received, it was quite clear that a lot of people were kind of skeptical about it first. But
I think that's healthy skepticism is good. It's a good thing. There's a lot of fakery out there that I can't wait to get this in production to show that it's real.
Yeah,
that's the litmus test. The next 5 months, 6 months to get this car into production will define us. Until we've got it into production, we've not achieved a damn thing. I'm super proud of what the team's achieved today. It's absolutely amazing. It's a brilliant team effort. Someone said about designing a car. Let me tell you, no one person designs a car. I've never claimed to design a car in a project that the only car I've actually designed myself was the car I built myself back in my garage in England, which led to this whole adventure in America. But that's another story.
Yeah, maybe you can tell me about that some other time then.
And built it with my own hands. But no one person designs a production car. This is a huge team effort. There was a huge team that I built at Tesla to do Model S, and I was happy to lead that team. That was my role. Brilliant, brilliant team. Part of my job was to build that team, and the team designed the car. And it's the same at Lucid. Many of my old Model S team have come across and joined me. I'm so thrilled to have them. He's brilliant talent. And we've got so many others that have joined as well on this mission to create the best car in the world. So it's a huge joined up team effort that does this. Now, I can understand the skepticism because what we're showing is unexpected. No one would expect a little company that no one's ever heard of to advance the state of the art in a way that we've done. But these aren't just wild claims that we're making. I've shown every step of the way, proven with independent observers that the performance is real. We claimed that we've got incredible range. We had it independently validated. We actually issued a report. The FEV report was issued with our press release for the 517 miles range. We redacted some elements of that report. Of course we did, because the engineering community would tell in milliseconds exactly how we've done it. And I can't let the competitors see those numbers. But the inherent report from FEV was published with our press release. And then we backed that up with real-world range tests with Bloomberg, Motor Trend, and Car and Driver. And also for two of those three runs, Car and Driver and Bloomberg, we ran a long-range plus Model S with us, and both those tests we achieved over 100 miles more range in real world than the Tesla. And in the case of the Motor Trend independent test, we achieved 490 miles range in real world, going about 70 miles an hour on the freeway, 65, 70, with the aircon on. No one's got a car like that. And that was independently validated. Those cars carried sandbags to represent the production car weight, because they didn't have full production interiors. So we carried sandbags in the car to weight them down to representative weight. And those journalists saw all the technology under the hood that they were driving in. This was absolutely bona fide. The problem is, I think a lot of the skeptics are perhaps unaware of just how exhaustive and how great are the lengths we've taken this to show that it is real. You've shown. We had journalists present when we did the quarter-mile run, the standing quarter, and we did a 9.24 run. Now, that 9.24 seconds run that we did was with narrow tyres. And I hit 158 miles an hour that day on the standing quarter. That was me driving with standard road tyres, narrow tyre. Our performance is much greater than that. And there were journalists present to observe that. So I understand the scepticism in some quarters, but probably they're not aware of the level of integrity that's been taken here, and the degree of scrutiny from impartial observers. What people haven't seen yet is the car in production, and that skepticism is totally justified. There's a huge step to getting into production, and very cognizant of that. And I think it's healthy that people are skeptical about us until we prove that we're capable of mass producing this car. I think that's justified.
Yeah. Well, I'm really looking forward to seeing how your production gets started, and really hope that you are able to keep everything on target, and we see those cars coming out next year. Now, as we talked about the range and we talked about the efficiency, I have a few battery related questions here as well. For instance, are you planning to, so as far as I know, you've chosen LG Chem as the battery supplier. Can you tell us what batteries are you using?
Well, they're 21700s, cylindrical, and we're using many thousands of them. We've co-developed the cell chemistry. They have committed to a multi-year supply deal for us. So we've locked in our supply with LG Chem. And we've also co-developed the internal architecture of those cells to be compatible with our connection technology that minimizes the resistance of a pack as a whole, because the losses inside a pack, the I squared R, the current squared times resistance, you want to reduce the resistance as well. So the lower you can get your pack level resistance, the more efficient the pack is, the less heat will be given off. And then you can have smaller radiators, and then you can have better aerodynamics on the car and create a beneficial circle. So yeah, LG Chem are awesome partners for us in this respect.
Okay. How does Lucid's battery future look like? As you probably know, Tesla is taking very aggressive steps to increase its battery production in order to meet global demand, while they're driving the costs down. So does Lucid have plans to do something similar? Will the company make its own battery cells one day, perhaps?
I'd love to. We're too small. We're back where Tesla was back in 2011, 2012 as a company now. Tesla didn't have a gigafactory for batteries. It couldn't have afforded it. We're at that stage. We're really developing our plans in that respect right now. Right now, we have to use world-class partners. I'm very delighted to be partnering with LG Chem. We've also got, of course, a great relationship with Murata. Our racing packs for the World Championship of single-seater electric racing, Murata supply the cells for that. I think we need to draw a differentiation here, Harry. I think there's a big difference between pack level supply and cell level. You know, if you look at Chevy Bolt, LG Chem supplies in the complete system effectively. With Lucid, LG Chem supplies us with cells, co-developed cells. The pack technology is entirely 100% Lucid's technology at pack level. The way those cells are put together to create a battery pack is our technology, and I believe it is significantly more advanced than anyone else's in the world. We use end cooling, for example. Tesla's don't use end cooling. There's talk that they might get towards end cooling. They use side cooling, even for Model 3. End cooling is the next generation technology. That's the tech that we're using from the E racing and the technology that we're using on Lucid Air. Cells don't like to transmit heat sideways. They like to transmit heat axially. It's a bit like thinking about a carpet. If you roll up a rug or a carpet into a spiral, now if you sort of blew hot air down into that spiral, the air wants to come out down the end of that rolled up carpet. It doesn't want to come out sideways through the carpet because the carpet's a very good insulator. This is the best analogy I can make.
Yeah.
Because inside a cylindrical cell there's this jelly roll which is rolled up, a bit like how you roll up a rug. You get a carpet into a roll to take it away. And actually that transfer of heat along the length of the cell can be about 20 times better than the sideways heat transfer. So, but the worst place you can try to cool a cell is the side of the cell. You do not want to cool it from its side. And yet Tesla packs are all cooled on the side. And there's other reasons. It's not just the heat transfer. It's the geometry of trying to match curved surfaces to get a consistent contact area. Getting a contact over a flat end of something is much more repeatable and consistent. So we're using end cooling for Lucid Air, which is the next generation technology. And that's just one example. And of course, then you don't have to run tubes between the cells. So you can put all the cells close together in a 60-degree honeycomb pattern. And that's one of the reasons our packs are more compact than Tesla's.
Okay, that cooling system you described, it sounds something what Tesla is now planning to do with their new 4680 cells that they unveiled. And
I think they're planning to do it.
Yes.
We're already there, and we've been doing this for a number of years with racing.
Okay, so that's, I would say, one advantage Lucid has against Tesla currently, and good on you for that. I mean, that's That's a good thing to see that somebody else already thought about something that Tesla didn't see before, and you're already implementing it in your vehicles. So,
and then the other thing that people are really quite interested in at the moment is the cell-to-pack concept.
right.
I'm not new with cell-to-pack. It's something I actually looked at on Model S. So, cell-to-pack has been in our thoughts for over 10 years now. Something I started looking at in 2009. It's got as many disadvantages as advantages. It sounds very attractive, but the advantages aren't as profound as perceived, and there are disadvantages which are not, that many people are not aware of. So we decided not deliberately to go for modular design for Lucid Air, not go to cell-to-pack, for good reason. It's not that we couldn't go to cell-to-pack, we could have done that. We just think it would be a really dumb solution for our application. So that's something that people are obsessing with really not the right depth of understanding of the subject matter.
Right. Well, there's no point in copying somebody else's technology if you have something better that's working in your application.
Yeah, I mean, one of the advantages with the modular design is that if you've got a really mass-produced car, and you're going to, like do a $25,000 car, and it's all going to be the same, and you can just put all that investment in, then I think cell-to-pack is probably a pretty good solution. But if you've got a car which is higher end and you want to give seating options and different variants of the car in terms of range and functionality, the flexibility that a modular solution gives you is awesome. And there's also an interesting economic trade between the two solutions as well. Which is far less clear-cut. But for us, I'm absolutely confident that it wasn't that we couldn't do cell-to-pack, we chose not to. And it's the right solution for us. That is the right answer.
Okay. So I have a few questions about your autonomous self-driving technology. We didn't hear too much about it during the unveiling, except that we did see that you have cameras and LiDAR. So is Lucid making its own autonomous hardware and software, or is there a partnership with another company?
We've got partnerships in place. So we've got the most comprehensive sensing suite for self-driving that we're aware of. We've got 32 sensor suite, including 120-degree LiDAR. So we're fusing LiDAR, surround view radar with long-range radar and cameras. We have about 14 cameras on the car, including driver monitoring. So we have the most comprehensive sensing suite. We have supercomputing processing capability on board, and a 2 terabyte data storage. And so this is an awesome system. The team is led by Dr. Eugene Lee, who I recruited from GM Hyundai, and he really is known as the father of GM Super Cruise. So we have an awesome team, and we're building that in-house. But Harry, I'm aware of the enormity of this task. We're starting an electric car company. We're going to come out with an awesome car next spring with the best sensor suite on the market. And we're going to catch up pretty fast on the software side through 2021 and 22. And we will get there. We can't do it, literally cannot, as a little company, do everything to really sort of be ahead of the competition in every respect on the car right now. I believe that our powertrain, I know that our powertrain is 17% more efficient than the nearest competitor, the leader in electric vehicles. So we're considerably ahead in terms of our core EV technology. I believe we've got the lead in terms of autonomous driving and ADAS sensing and sensor fusion, we need then to push like crazy over the next 2-3 years on the software side.
Why did Lucid choose to go with LiDAR and cameras? As we've come to know, LiDAR is much more costly than cameras. Furthermore, the LiDAR is mounted in the front of the vehicle, and as you said, it's 120 degrees, which as opposed to being on top of the vehicle. How exactly does this work?
Well, I think what I believe in is a multi-layered redundancy in sensing. A horses for courses approach. So we fuse long and short range radar with long and short range cameras, different viewing angles, and LiDAR. And there's a very interesting precedent here in the human body. We fuse vision with inner ear for our balancing system. And if you close your eyes, you don't balance so well. If you've got a cold and your inner ears are blocked, sometimes we don't balance as well. So I think there is a sort of analogy here, which has been developed over the eons with the way the humans interact and react with their environments. Now, of course, the LiDAR has got a shorter wavelength light wave. It can get more granularity and detail of the topology around the car than radar, but it's more vulnerable to interruption from spray and fog conditions and things like that. So, but I just think there's a power in having this sort of multi-layered fused effect. And that's what we're investing in.
Okay, well, as you probably know, that there are 5 levels of autonomy. At which level will the initial vehicles will be? Like, will they be at level 2, level 3?
Yeah, it'll be level 2 plus, and we'll move towards, let's say, that's hands off, and then we'll move to level 3, eyes off. Within about 18 months from the start of production, and that will be through software upgrades. You don't need the sensor upgrades. The platform is effectively level 4 capable. Our sensing suite for SAP, start of production, is level 3 compatible.
Okay, that was going to be my next question, because I wanted to know if you're striving to achieve level 5, and if so, what's your timeline? But
I don't know about level 5. I think that is a huge intellectual challenge. I think that if we look at just level 4, best guesses, and no one knows for sure, Harry, it could be 10 years and $10 billion away just for the software piece. This is many times the cost of creating a successful new electric car company. And we're talking about just the software for autonomous driving level 4. I think it's a huge intellectual challenge which has been underestimated. I've not changed my view of this in many years. Actually, if you'd asked most people 3 years ago, I was condemned as a dinosaur. Most people felt there were going to be whole groups of robo-taxis level 4 by 2019. It hasn't happened.
Yeah,
I've actually been proven right on this one. Who knows? It's a matter of when, not if. It's inevitably going to happen. But give it 10 years before we get to level 4.
Right. Yes, I also actually agree with that. I don't think level 5 is going to happen as soon as people think. Level 4, maybe, but level 5 definitely might be more than 5 years, possibly 10 plus years away, because it's all about those small corner cases. You can get to level 4, but then from level 4 to 5, it might be a much longer journey than most people anticipate.
Yeah, I can't even think about level 5. My guess is level 4, And don't get me wrong, it would be a wonderful thing if it happened earlier. I'm just being pragmatic.
Exactly. Do you have any plans to release any lower budget cars in the future?
Oh yeah, no, I'd love to do that. The world needs a $25,000 electric car, and this is so misunderstood. People have said, well, why on earth are you doing another wealthy man's electric car? That's not what the world needs, Peter. And this is, again, it's so misunderstood, Harry. Creating a new Rolls-Royce is a much smaller project than creating a new Volkswagen Golf. You think of it, the Volkswagen Golf needs a huge factory, a high degree of automation. It's a numbers game with low margin. Whereas the Rolls-Royce requires a relatively modest factory, large camp build. That's a tiny project. Now, we don't want to be playing in the Rolls-Royce arena because that's never going to change the world. We're going in Mercedes-Benz territory with Lucid Air. But I want to grow the company and grow the impact. What motivates me is the impact upon the environment that we can make with our products. And that's why it's so important that what we design in terms of our powertrain for Lucid Air is truly mass producible. That's a real passion of mine. Now, we've just announced that the Air, the most attainable version of the car, will be available at $69,900 with a federal tax incentive. But that's still an expensive car. So we need to wait till Platform 2 to bring that price point lower down. And, even now, it's now, 8 years or more since Model S was produced, Tesla still isn't at the point where it can create a $25,000 electric car. I'd love to do that. Realistically, it's going to take Lucid another 6 or 7 years before we could even grow and get the company to such a level of maturity where we could countenance such a project. And that's why I've said, maybe we can sort of jumpstart this whole thing, leapfrog that process by making our technology available to other car companies. That's what I'd love to do. And it may be that you'll see a $25,000 electric car with Lucid Powertrain technology in it, but it won't have a Lucid badge on it. It might be another car company. And maybe that's the way that we can have the most impact upon accelerating the adoption of sustainable mobility, because I think we've got a real issue with the environment and that cannot wait. And it's my passion to try to speed up the process of that adoption.
Have you been in talks with any company at the moment who would be interested in buying or licensing your powertrain technologies?
We've had a few chats with we've been approached by a few companies, and even quite recently I've had a few discussions, but there's nothing I've got any tangible yet to announce. And also, it's fair to say that my focus, the laser focus of the company, is to get Air into production. We can't afford these distractions right now. And so I want to get in production, prove the concept first, and then I think we can have such discussions thereafter.
What's the current status of the factory you're building? Is it? Yeah, go ahead.
So we started construction just on a piece of dirt in Arizona in December last year, and last month in September we actually had cars coming down a pilot line, a prototype line in the factory. We've pretty well finished construction of the buildings now in the car park. We've even got cacti planted in the borders of the car park. It's at that level. I was discussing what flag posts we put outside this morning with the team. We're still fitting out the final touches to the equipment inside the factory. Right now we're doing something called TTO, tooling tryout, and that's where the robots are just tweaked. They're fed production tool parts for the first time, because up to now they've only been fed some prototype parts. So you start feeding the robots the actual parts, and there's slight differences, and the robots have to be just adjusted so that they fit and they can feel their way assembling the actual parts that are going to be fed with in production. That's the tooling tryout, the TTO. And we're doing that now. So our robots are twitching and moving and being fine-tuned. We're bringing up the paint shop in the third week of November. We've got a state-of-the-art Dur paint shop, German paint shop, truly the best you can get. We've made a big investment in our paint building. You see two buildings in pictures of our factory. Together we can make 34,000 units a year with those two buildings. But we've designed a whole architecture like a game of chess, really. We've got a 4-phase plan for that site, and we can take that up to nearly 400,000 units a year. Now, what we've done is chosen to invest in a really significant paint shop. That's the big building you see in the background of the pictures of our site. And that structure is big enough to have a paint shop which will serve the full 400,000 units in 5-6 years' time. We've made that long-term investment. And that's really exciting. That's coming to life, the first phase of that paint shop, late November. And we'll have painted bodies probably the last few days of November, leading into our RC build there in December. It's really close now.
Okay. Sounds like you're still on track for early next year release for the Lucid Air, the higher end production model, and the lower end sedan that's now $69,000. That was going to come out in 2022, was it?
22. I wish it could come sooner, but that's when it's scheduled.
Okay.
So what we'll do is we start with the technological tool of force, the product that defines us, the Lucid Air Dream Edition, over 1,000 horsepower, standing quarter, 9.9 seconds. The thing is off the planet awesome, over 500-mile range. This fusion of range and performance that everyone said was impossible, being said it's impossible to do this. And we've broken that. That paradigm's been cast to the wind. So we'll bring that car out first, but that's relatively low volume because there's not many people in the world who can afford a car at $169,000. And we'll move then to Grand Touring, which will be from $135,000. And we'll move to Touring, which will be from $95,000 late next year. And then Lucid Air, the most attainable version, the foundation stone for the whole range, Lucid Air. And in some ways, a very cool car because it won't have the glass canopy roof. It'll have a metal roof, so it'll be more enclosed. Different feel to the car. From 69,900 in early 22.
That model also won't have the reclining seats, would it?
Now we're going to bring out the reclining rear seats as a super luxury package, and the plan is to bring that out early 22 as a precursor to going into China, because I think that's just perfect for the Chinese market.
Okay. Are you planning to expand your production to other countries, just as Tesla did, to avoid increasing the costs when shipping vehicles to overseas?
Oh yeah. I mean, I'd love to have to do something meaningful in the Kingdom of Saudi Arabia. The Public Investment Fund are our investors. Quite exciting possibilities there we're discussing. And then big picture, we've got to do something huge in China. So a plant in China in the next few years is very much part of the landscape for us as well. Yeah. Right,
because China, as you know, is the number one when it comes to the EV market. They have the largest EV market in the world currently. So it only makes sense for you to expand to China as well, right? I have a question from one of my viewers here who asked, will there be an option for a trailer hitch for those who would need to transport, for example, their mountain bikes, for instance?
That's a very good point. It's something we've overlooked. I haven't done that yet. But I'll put it on the list. I'll ask the engineer.
Okay.
Thank you for the suggestion.
Yeah. Since you mentioned suggestions, is Lucid as a company open to new innovations from outside sources? Like if let's say there are people, smart people out there, engineers who come up with revolutionary breakthroughs, would Lucid be open to consider taking those technologies and then implementing?
That would be interesting in hiring them.
Okay.
They're that good. We wouldn't stop at the technologies. We'd want to hire the inventor as well.
Right.
I want Lucid to be a mecca for such innovation and ingenuity and brilliant people. Yes, come on board.
That's good to know. I personally believe you already have a really great team working for you.
I do. I'm blessed with an awesome team. So many came across from the Model S team. We got the brain trust from that, and so many others from all corners of the world. It's very cosmopolitan. There's all nationalities, all races and creeds, and we're richer for it.
Great, that's good to hear. Before we wrap this up, I want to say that this interview couldn't have happened on a better day because EV Source, my channel here, just reached a milestone of 30,000 subscribers last night, and I couldn't think of a better way to celebrate this than interviewing one of the most known names in the industry, which is you, from a company that I think will be one of the biggest names in the industry one day alongside Tesla. So thank you for making my day.
I hope I haven't lost you any subscribers. I hope they go up after this, not there.
I hope so. I hope so. Thank you for taking your time for this interview.
It's been a pleasure, Harry. And thanks for what you're doing for the movement, because I think that we're all part of this important movement. And I think that's what people shouldn't overlook. Right now, it's kind of David and Goliath. You've got little Lucid. But what we're trying to do is we're trying to make the world a better place. And there's 1,000 or more really decent, honest people back at base working like crazy, trying to improve the world for all of us. And we shouldn't lose, the cynics shouldn't lose sight of that.
I couldn't agree more with that. The world needs companies like Tesla, obviously, but you are definitely on the right path, in my opinion. And I believe the world needs companies like Lucid, Tesla, to take things to the next level and bring the EV revolution to the common people, so that everybody has access to this new revolutionary technology and the new way of transportation. So whether it be just electric vehicles or autonomous mobility, I think what you are doing with your company is really great, and I personally appreciate a company like yours who is taking such leaps to bring this technology and bring this future and make it a reality. So I'm really grateful for having such companies exist and show others that, you know, this is the way to do it. This is how we should move forward.
Thanks so much. We're trying our best.
Thanks. I wish you all the best.
Thank you very much.
Thanks. Thank you. Bye-bye.